So what we're going to do now is have a look at a redox half equation example. Okay, so we've got an equation here where we've got a copper ion and some solid aluminium metal reacting to produce solid copper metal and an aluminium ion. Okay, so we could look at this and balance it pretty easily just by looking at the charge, okay, and making sure the same number of charge is on either side. Okay, but what we're going to do instead is we're going to use redox half equations to balance it. Okay. So firstly, we want to get a reduction half equation and an oxidation half equation. And to do that, we need to figure out which out of the copper ion and the aluminium is being reduced and which is being oxidized. Okay. So what we'll do first is we'll label all the oxidation numbers. Okay. They're pretty simple here. We know that copper has an oxidation number of +2 because it's an ion with a charge of 2+. Aluminium has a 0 oxidation number. Solid copper has a 0 oxidation number, and aluminium has a +3 oxidation number. Okay, so that means we know that copper is being reduced, okay, because its oxidation number goes from +2 to 0, okay, and aluminium is being oxidized, okay. Okay, so what we do first, we'll write the reduction half equation, okay. So we'll write reduction here. So that's the reduction half equation, okay? So we know that we start with copper 2 in solution, okay, and we're producing copper in solid form. Okay, and so we know we need to conserve charge here, okay, so what we're going to do is we're going to add 2 electrons here. Okay, it's pretty obvious that 2 electrons need to be added because the copper 2 ion has a charge of 2+ and has therefore lost 2 electrons compared to the solid copper. So therefore, if we add 2 electrons to the copper 2 ion, we end up with solid copper. Okay, so that's the reduction half equation. Now we'll have a look at the oxidation half equation. Oxidation half equation. Okay, so starting out with solid aluminium. Okay, and what we're doing is we're ending up with aluminium 3 ion. Okay, we need a balanced charge again. Okay, so we can see that we need to add 3 electrons. Okay, so here we've got the 2 half equations. Okay, and we want to add them together to create recreate this top equation, except we want it to be balanced. Okay, so what we're going to do is we're going to multiply these equations by the appropriate numbers. Okay, so we're going to multiply the top equation by 3, this equation by 2. Okay, so the reduction equation becomes 3 copper 2 plus 6 electrons produces 3 solid copper. Okay, and the oxidation half equation becomes 2 solid aluminium plus 6 electrons. Okay, pretty straightforward maths. Okay, and so now we see we've got 6 electrons here, 6 electrons here. Okay, so if we add these together, the electrons will cancel out. Okay, so get rid of that. And we have 3 copper 2 ions plus 2 solid aluminiums producing 3 copper atoms and 2 aluminium 3 ions. Okay, so what we could have done, we could have just looked at this and seen, okay, we need to put a 3 here and a 3 here and a 2 here and a 2 here, and that'll balance the charge, okay? But what we've done instead And we've used redox half equations to help us do that. So we've identified the reduction half equation and the oxidation half equation. Okay, we've multiplied them by appropriate numbers so that we can add them together and cancel out the electrons, because we can't have any electrons in our full equation. There were no electrons up here. Okay, so we multiplied them by appropriate numbers, added them together to cancel out the electrons, and we found out that we still get three copper 2 ions, 2 aluminium atoms, 3 copper atoms, and 2 aluminium 3 ions. Okay, and so that's how we can use redox half equations to help balance, balance an equation, even though we've only done a very simple one here.